Welcome to Okonkwo Academy. In this tutorial, I'll be taking you through solving separable differential equations. Now, there are various forms of solving differential equations, of which we'll be doing all of them as time goes on. But for today, we want to tackle the separable method. As usual, please do not forget to like, comment, and share this video to your friends. If you are a new person here joining us, please do not forget to subscribe. And you can also put us on post notification so that you can get an alert or notification on all the videos that will be uploading later. Now, like I was saying, with the separable method, it comes with two easy steps. So we'll be going through those steps, and then I'll be using this example that we have here. We'll be using this example we have here to go through those steps. So, the first step when it comes to separable differential equations, the first step that you need to do is to group like terms. I repeat, group like terms. What do I mean by that? You realize that we have n of y dy is equal to m of x dx. What this means is that all terms containing y should be grouped at one side. That is, whether it may be y itself or 2y, 3y, y squared, and its derivative as well should be grouped at one side. And then the same thing goes for the x's, or the independent variables. The same thing goes for that. All the terms are grouped at one side as well as its derivative. If we take our example here, we have dy dx is equal to 6x plus 5 all over 2. There's a condition here, but then we will come back to that. Our focus now is to solve this differential equation. So, when we take this example, you realize that we can simply do cross multiplication for this, right? What do I mean by that? We have dy over dx equal to 6x plus 5 all over 2. If we cross multiply this, we want to group like terms, right? And the reason why we are cross multiplying, this 2 here can be assumed that it has y exponent 0. So it is also a y term, right? So we have 2 dy all equal to 6x plus 5, which is also having dx, right? So you realize that our equation here resembles what we have here, ny being our 2 and m of x being 6x plus 5. The next thing we do here is to what? Integrate at both sides. And that is it. That is all about separable. You group like terms, you integrate, and if there are further simplifications, you just do so, right? So the next thing here is to what? Integrate at both sides. So we are integrating 2 dy, we are integrating 6x plus 5 dx. So when you integrate 2 with respect to y, right, what do we get here? Since we are assuming that our y here is 0, in integration we know the power is 0, so 0 plus 1 gives you 1 divided by the new power, which is 1. So we end up getting what? 2y equal to, now 6x, right? The same thing applies to this place. So we get 6x squared, because the power is 1, so 1 plus 1 is what? 2, divided by the new power, which is 2, plus 5x, the same way that we did the 2y, the same situation is happening with the 5, so 5x. Now, do not forget that whenever you do integration in definite integrals, it always has a constant, right? So we actually forgot to put a plus c here, right? So this is plus c, and this place is also plus c. But then we can choose to group all the constants at both sides, right? If c moves here, we can get c minus c, which is 0, but that still makes it a constant. So everything can be moved here and made a c, right? So you can simply get rid of this side, sorry, I think my eraser is fooling a bit, but then we understand the whole concept now, right? So now all we do is to further simplify, right? We simplify. So we have 2x here. If we want to divide by 2 here, we get 3x squared here. And then with this side, we also have the 2 dividing through all. So we get y equal to 3 on 2x squared, right, plus 5 on 2x, all plus. Now remember the same way we did c minus c equal to 0. If you divide a constant by 2, you are still getting a constant, right? So all this place is still c, and that is it. So this is our differential equation, right? But then remember I said we'll come back to this. We were given a condition. What is the condition? They said y of 1 equal to 24. So when x is equal to 1, y is equal to 24. So let's insert this condition into our equation, and that will help us get this constant. I hope you get me. Sure. So we have y of 1 equal to 24. So we have 24 here equal to, now we know 1 squared is what? 1, and 1 times any number is the number itself. So we have 3 on 2 plus, and then 5 on 2 also multiplying x, which is 1. It's also giving you what? 5 on 2 plus c. Now we have 24 equal to, we are getting 3 over 2 plus 5 over 2. Since the denominators are the same, we can simply add the numerators, right? So 3 plus 5 is giving us 8. We are getting 8 on 2, which is also what? 4, right? Plus c. And then our c now becomes what? 24 minus 4, which is now equal to 20, right? So this is the value for our constant c. So we can simply just come and put it here. So we have y equal to 3 on 2x squared plus 5 on 2x plus 20. So this is our equation now. This is our final equation. Okay, thank you very much for going through this example with me, and I'll see you in our next video.